Okay, let's talk about graphing and solving quadratics in Vertex form. All right. So before we do any of this, let's do a quick review on a couple topics. One is transformations, right? So graphing with transformations, and the other is completing the square. So let's start with transformations first. So remember that transformations of any function, right? So f of x just represents a function, and I'm going to make it where the c, the constant, is positive. So greater than zero just means positive. If this is true, then when I add c to the outside of the function, this is why c is positive, right? So plus c would be plus positive number. This will make the function go up, or remember, it also does this, right? It adds c to all the y values. They're synonymous, but there are two different ways to think about it. Now, if I subtract c, so if I subtract a positive number, I'll make the entire graph or function go down c. Or in essence, I'm subtracting c from all the y values. All right? Okay, if I multiply by a negative on the outside, then this will reflect over the x-axis. Or what will happen? It's changing the sign of all the y values. All right, so remember in transformation, when you do stuff to the outside, so outside of the function itself, this is going to affect the y values. All right? Okay, we can also do this for x values. Well, what if I do x plus c on the inside, on the input? Well, this will move the graph or shift the graph left to c, or it's the same as subtracting c from all the x values. All right. If I subtract a positive number, that'll move the graph or translate right c, which is the exact same thing as adding c to all the x values. All right. A negative on the inside is a multiplication will reflect over the y-axis. Right. And why is this? Because what we're really doing is changing the sign of all the x values. All right. So now in transformations, remember, when you mess with the inside, the inputs, this affects the x values. And it's always the inverse of what you think. Remember, when we mess with the inputs, we need to compensate for our transformations or our additions, right? Or what we mess around with. So when I add c, the compensation is to subtract c from all the x's. When I subtract c, the compensation is to add c to all the x's. All right? So it's that kind of stuff. All right, so let's do this. Let's do graph y equals x plus 2, the whole thing squared, minus 3. Well, notice that I know the graph of y equals x squared. This is simply just the vertex is at 0, 0. As I go to the right one, I go up one. As I go to the left one, I go up one. So right off 1 unit left and right of the vertex, I just go 1 unit up, right? So 1 squared is 1, negative 1 squared is 1. So really all I need to do is apply the transformations of these 3 points, right? So what are the transformations? Well, the plus 2 is going to be left 2, right? So I'm adding 2 to all the inputs. Remember, I have to compensate, so that means left 2. And I really like to think of it better as that means subtracting 2 from all the x values. Right? So then you can see on my original x squared graph, I have 3 x values, and to get the new x values, I'll just subtract 2. And the plus 3, oh, I'm sorry, it's a minus 3. So the subtract 3 is going to be down 3. So what am I really doing? I'm subtracting 3 from all the y values. So my new points, the 3 points here, I'm going to subtract 2 from all the x's and then also subtract 2 or 3 from all the y's. So my new graph will look just like this. Left 2, down 3. All right. Okay, so you can see it's very easy to graph things when they're in this vertex form. And that's what this perfect square form looks like, or that's what it's really called, is vertex form. Because you can see the 2 and negative 3, since it's a plus 2, I know it's going to be compensate, so negative 2, and then negative 3, right? So negative 2, negative 3, that's the vertex. That's why they call it vertex form, all right? Okay, let's try this one. So I have 2x minus 8 squared plus 1. It's vertex form, which is nice. So again, I know the original graph x squared, so all I need to do is transform these 3 points. Let's figure out our transformations. So the first one is I have a 2 times the x. So remember, the 2 as a multiplier will compress horizontally by a factor of 1/2. Right? Or again, how I like to think of it is it'll divide all the x's by 2. Right? So that's the 2x. Now the minus 8 you would think would go right, that's the minus, and you think it would go 8. But remember, we have this 2, this compression. So any translations I do have to also be compressed. So it doesn't go right 8, it goes right half of 8, which is 4. Okay, so that's how you're going to compensate for numbers as multipliers and numbers as addition subtractions. All right. All right, and then the plus 1 is just up 1. So we're going to add 1 to all the x values. All right. Okay, so what do we have to do? We have to add 4 to all the x values. We have to add 1 to all the y values. And we have to compress all the x values by a half. All right, so I'm going to compress this -1 by a half, which makes it -1/2. Then I'm going to add 4. That's how I'll get a 3/2. All right, and then I'm going to add 1 to this y, or subtract 1. Oops, I did plus 1. So we're going to add 1 to the y value. All right, and you'll see if I do that to all 3, this is what I get. I compressed the x values first, then I shifted them or added the 4 to all the x values, and then I added 1 to all the y values. Okay? All right. So you want to stop this and complete classwork problems 1. Just do A, C, and F. Okay, so now let's do completing the square. So remember, completing the square, your understanding of completing the square comes from your understanding of distribution. So if you have a perfect square, x plus a, which is just squared, which is x plus a times x plus a, if you did distribution, you'd get, right? So this x times all of these, and then this a times all of these, and this is what you get. X squared plus ax plus a squared. Combine the x's, right? You have one ax and then another ax, which means you have 2 of them. So x plus a, the whole thing squared, is the exact same thing as x squared plus 2ax plus a squared. Well, if that's true, if we're given this middle piece here, so I have x squared plus 6x, which really corresponds to this x squared plus 2a times x, all I'm missing is this a squared. So what I'll do is I'm just going to rewrite this 6 as 2 times the a value. So this is really 2 times 3, right? And how did I get that? I just cut this 6 in half. That's what tells me this has to be a 3, right? And you'll notice whatever this is, this a here, that's also what has to be squared. So that's how I get the 3 squared. So in math, I can't just add anything I feel like, but I can add a 0. So remember, if we add a 0, it doesn't change it. It just changes the way it looks. So I really wanted this plus 3 squared. So to make it a 0, I did a minus 3 squared. So in essence, this is just a very clever 0. Okay, all right. So now these 3, which I'm going to change it back to a 6x. It's just x squared plus 6x plus 9. And then all I need to do is factor this. Well, what factors of 9 add up to 6? Well, 3 and 3. So that's why it's x plus 3 times x plus 3. And that minus 9 just comes along for the ride. All right? Okay, so let's complete the square on this. So notice this is a little different. So I have a number out front, which is the 3 times x squared. So recall that we can't have that. Right? So I want to complete the square on this 3x squared minus 12x. Right? So remember, when I complete the square, it's give me any x squared and it's x, and I'll be able to complete the square on these 2. Okay, but I can't because there's a 3. So let's factor out the 3. So I get 3x squared divided by 3 is x squared. Negative 12x divided by 3 is negative 4x. And so this is me pulling out or factoring out the 3. Well, now I have x squared minus 4x, and this is exactly like the problem we just did. We'll cut this negative 4 in half and add that squared. So negative 2 squared is 4, and we have to do our clever 0, so we'll also do a subtract 4. And now these 3 terms in blue, what are the factors of 4 that add to be negative 4? Well, they're negative 2. So this will be 3 times x minus 2 times x minus 2. This is just factoring. And then I have this negative 4, this minus 4 that comes along for the ride. So I'll get 3 times x minus 2 times x minus 2 is 3 times x minus 2 squared, and 3 times negative 4, which is a negative 12. And now my last step is just to add up these like terms. So negative 12 and 15 is just a 3. All right, so completing the square is just the same as when we discussed it in previous lessons. And when you have a coefficient out front of the x squared, you have to factor that out before you can complete the square. Okay? All right, so I'm going to stop the video and do classwork problems 2A and B. Okay, so now the whole point of this. So we're going to use completing the square and transformations to graph quadratics. So I want to graph x squared plus 6x plus 7. And I want to graph it by hand. I don't need a calculator. I don't need technology. I can do this all by myself. Right? Well, I can't do it when it looks like this. Right? I need it to be in this vertex form. And I know I'm changing the notation a little bit. I'm making this a minus h, but we might talk about that later. The point here is it's a perfect square, right? That's what we need. And a perfect square is completing the square. So I'll do my x squared plus 6x. I'll plus 7, but all I need is x squared plus 6x. I only need these 2 to complete the square. So let's take half of 6, which is 3, and I'll add 3 squared and subtract 3 squared. So here's my clever 0 right here, plus 9 minus 9. And then how do I factor x squared plus 6x plus 9? So what are the factors of 9 that add to 6? Well, they're 3. So it's got to be x plus 3 times x plus 3. And then these, negative 9 plus 7, is just minus 2. All right, so this x squared plus 6x plus 7 is the exact same thing as x plus 3 squared minus 2. And now you can see this is vertex form. So I just have to apply my transformations, which are left 3, right? So this plus 3 is left 3, or subtract 3 from all the x values. And minus 2 on the outside is down 2, or subtract 2 from all the y values. So take your original x squared graph and subtract 3 from all the x's and subtract 2 from all the y's, and this is what you'll get. The dotted one's my original, right? So here's the vertex 0, 0. Subtract 3, subtract 2, now it's at negative 3, 2. Right? Here's negative 1, 1. Subtract 3 is negative 4, and then subtract 1. Oh, I'm sorry. So it's 1, 1. So negative 4, and then subtract 2 is negative 4, negative 1. So you can see I'm just transforming those 3 points. All right, so that's what this is all about. Take quadratics, complete the square, and you'll put them in vertex form, and they're simple to graph. Very simple to graph. Just use transformations. Okay, so if you want to stop this and complete class work problem 3. All right, our last piece is, you'll notice if it's a perfect square, then I can actually solve this easily. All right, so when it's just a perfect square, there's only one single x here. So you notice it's not x squared plus 6x, it's just an x, which means all I have to do is inverse operations. So get rid of the 16, get rid of the square, get rid of the 3, and then the x is all by itself. So I can solve this just by doing inverse operations. All right, so the first inverse operation is add 16 to both sides. Now I want to square root both sides because I want to get rid of this square. And whenever you do a square root, always include a plus or a minus, because if this is 4, it's 16. If this is negative 4, this whole quantity, it's still negative 4 squared is 16. So you have to account for both the plus and the minus. All right? Well, 16 add 16 becomes 4. This is x minus 3 equals plus or minus 4. I'm going to add 3 to both sides. And you'll see this is common notation. We just put the numerical value here and then the plus or minus to the right. So this reads 3 plus 4 and 3 minus 4. So there are 2 equations here. So 3 plus 4 is 7 and 3 minus 4 is negative 1. So those are my 2 solutions. X equals 7 and x equals negative 1. You can see if we plug in the 7, 7 minus 3 is 4, perfect. And we plug in the negative 1, we get a negative 1 minus 3 is negative 4. We got the plus minus that we were looking for. All right. Okay, so that's how we solve just straight up perfect squares, right? When the x is, when there's only one single x in here and I can isolate with inverse operations. Right, what if I had something like this? So I had 3x squared plus 12x equals 63. Right, this is not a perfect square. Well, but we know how to make it a perfect square. So see how easy it was to solve that last problem? Well, let's do it here. I want to complete the square. So I want to complete the square on 3x squared plus 12x. I can't do it because the 3 is here, but I have an equal sign. The equal sign opens up a ton of options here. So all I can do to get rid of the 3, or all I need to do, is divide everything by 3. Divide 3x squared by 3, 12x by 3, and 63 by 3. And I'll get x squared plus 4x equals 21. So when you're given an equal sign, you don't actually have to do that factoring thing to complete the square. You just have to divide through by the leading coefficient. All right, now let's do our completing the square. Here's plus 4, so take half of 4 is 2 and square it. So I need a plus 4 here, and since I have an equal sign, I don't have to put a minus 4 here. I can just do the exact same thing to this side. All right, so in essence, adding 4 to the left and adding 4 to the right is my clever adding 0. All right? Okay, now how do I factor these 3? Well, what are the factors of 4 that add up to 4? Well, they're 2. So it's got to be x plus 2 times x plus 2, which is x plus 2 squared. And 21 plus 4 is 25. Okay, so now we're right where we were. So this 3x squared plus 12x equals 63 is the exact same thing as x plus 2 squared equals 25. So square root both sides, and that'll be a square root of 25 is plus or minus 5. Subtract over, so let's use our notation. This is a minus 2, then plus or minus 5. So this is a minus 2 or negative 2 plus 5, and a negative 2 minus 5. So I'll get a positive 3 and a negative 7. All right, so completing the square is very helpful when solving quadratics. Okay, so that's actually the end of the video. So you just stop this and complete class or problem 4.